Hello friends, today I am explaining the topic is CBR of soil, that is California bearing ratio of soil. The C means California. So initially this experiment is should be conducted, that is in California, that means they are found that experiment in California. B means bearing, that means how much it will bear the load or how much it will support or how much it will resist the load. Load in the sense it is a traffic load. So ratio means here they are using soil and standard aggregates. That means they are comparing soil to standard aggregates. Both should be in compacted state. So see, this is the loading frame. This is proving ring. This is dial gauge, and this is plunger. Bottom diameter of the plunger is 5 centimeter. The proving ring should be used for applying pressure to the soil, and dial gauge should be used for finding penetration. So here we will uh, we have to here we will put that is one CBR mode. So next, so see, in every 100-meter interval we have to collect the soil sample for finding CBR percentage in flexible pavement. That means for designing a flexible pavement, here CBR percentage is very important. This CBR, using CBR percentage, here we have to find various layers thickness. So see here, this is, we observing that various layers of the thickness using that test pitch. This is called as a test pit or try pitch. So different changes we have to use. So see, this is the various layers of the pavement. So one by one I will explain along with colors. So see, this is one color, and this is one color, another one color, another one color, another one color. So see here I shown here various layers. So that means the dark blue, so that should be or blue, the it should be used as a or that arrow mark whatever I am showing it showing here, so that is subgrade, and whatever green line I am showing here, that is subbase, and what is orange line I am showing here, that is base, and what is red line I am showing here, that is surface layer. So these are the various layers. So for finding thickness of the various layers, so this CBR percentage is very important. That's why we have to conduct CBR percentage. So that means every 100-meter interval we have to uh, collect the soil sample through trenches or tail pits. So and then same soil sample we have to brought to in lab, and we have to conduct CBR percentage. So in gunny bags we have to collect the soil sample, that is harder state soil sample, not for surface soil. So after 1 meter, so here 1 meter soil sample whatever is there, so we will not use it for finding any test. So after 1 meter only we have to dig the soil, and same soil we have to collect in gunny bags and we have to brought to lab. So because the top soil should be contain debris, because of that weathering action, so debris should be collected, we don't consider that debris. So now, so see, so whatever we brought soil to lab, so this is the soil. So for 4.75 mm passing soil we will be used, and we have to keep in oven for a period of 24 hours to maintain temperature 105 to 106 degrees centigrade, that is oven drain soil. Entire one day we have to keep in oven, so we'll, whatever we get the soil, that is in oven drain soil. So before conducting CBR test, so here we have to use modified proctor test. So in that modified proctor test, already you know the procedure of modified proctor test means here we have to collect soil. So for the whatever collected soil we have to add required percentage of water. So initially from starting from 8%, 10%, 12%, and then 14% and 16%. So for that soil we have to add any percentage of water and mix thoroughly, and we have to fill soil in that mold. So this is the mold. So in mold, layer by layer we have to fill. So each layer we have to give 56 blows. So using this rammer, so see, this is rammer. So this rammer weight is 4.6 kg. So for each layer we have to give how much blows? 56 blows. So after that, same for every percentage of water we have to continue. After that we have to draw OMC curve. So see, this is OMC curve we have to draw. So in that we will get OMC and then here MDD. We will get OMC and MDD. So that OMC MDD we have to use in CBR test. For example, in this stage we assume OMC is 12%, MDD is 2.1 gram per centimeter cube. So that OMC MDD here we have to use in CBR test. So in CBR test, same procedure of modified fruct test, only here one time mixing and one time compaction. Okay, so here take it 5 kg of soil. So same one dry soil, take it 5 kg, and before filling the layer, so we have to place spacer disc. So this is called as a spacer disc. So why it will be used means it will create space. So we want space. So why we want space means to placing the surcharge weight we want place, or we want space. So that's why we will place spacer disc, or we have to insert spacer disc in that mode. So after inserting, so we have to same 5 layers, each layer we have to give 56 blows. So for required OMC, for example, we got a 12% OMC means, so for a 5 kg directly we have to have 12% of water, and layer by layer we have to give 56 blows using 4.6 kg rammer, and after that we have to reverse the mode. Once it is reversing, so we have to remove that. So first, before reversing, first you have to remove this spacer disc. So if you shake the mode, it will come down. So after that you have to reverse the mode. So whatever created space in the top surface of the mode, so in that we have to place two surcharge wedge. So this is called as a surcharge wedge. So see here, up to this space will be created. So for that one we have to placing two surcharge wedge. So this is surcharge wedge. So see, after placing surcharge weight we have to keep in water. So here two conditions are there for conducting test. In two conditions, soaked, another one is unsoaked. So in unsoaked, directly entire assembly you have to place in loading assembly, and we have to conduct the experiment, and we have to find the CBR percentage. But in soaked condition, in this assembly we have to keep in water for a period of 4 days. So after placing 4 days we have to conduct the experiment. What is the reason we have to place in water, we have to keep in that entire assembly in 4 days to water means, the reason is the soil should contain clay particles. Once it is clay, what happens, it will be coming up. So on that case what happens, whatever soil, so here whatever surcharge weight is there, after removing this entire assembly to in one part, so we have to get some differences. So initially this before keeping in the bucket, the soil is in even surface. Once if you remove that bucket, what happens, the soil whatever is there, that is in uneven. For example, so if it is in soil, initially it is in, see, it is in straight line. Okay, it is in straight. After removing in bucket, what happens, the soil should get like this, or it should be get like this. That means this indicates what, it is in uneven, but here it is even. Before keeping the bucket, after removing in bucket, what happens, it will be uneven. Why it is uneven? Because sudden volume will be changes. The soil should be contain more clay, so like that we will get differences. So in that case we have to conduct CBR percentage. So here worst condition is in rainy season. That means soaked condition value we have to consider for design of flexible pavement. So see, this entire assembly we have to place in loading frame. So this is proving ring, this is dial gauge, and this is plunger, and this is mold. So in that case what happens, because of that plunger and load, some pressure will be developed. So that means some impression or penetration will be developed into the soil mass. For every 50 mm we have to note down the pressure or load. So that is the case in CBR test. So now coming to, so see, after conducting the experiment we will get this type of impression or penetration. So see here, this indicates what, if the soil should in smooth condition, that is fine grain soil, normally we will call it as a fine grain soil, it will contain more clay, that is more clay and silt. In that case what happen, we will get more volumetric changes or volume changes. So in that we will get more penetration. If we get more penetration or more impression, CBR percentage less. If we get less penetration, CBR percentage more. For example, I will give an example. you people you will take any one hard material and smooth material like sponge. So in sponge, so one second. So if you take hard material, so see, you will take one hard material and sponge. So in that sponge you will apply the load. What happens? You will get more impressions. Again, similarly, you will take any hard material. In that you will apply the load. What happens? You will not get any impressions. If it is get impression, that is will be lesser percentage compared to smooth and material. Why? Because it is a hard like that. Coarse grain soil, it will contain gravel and sandy soil, it will get very lesser penetration. If the black cotton soil, it should be get more penetration. So if the penetration should be less or impression should be less, that is CBR percentage is more. If the penetration is more, CBR percentage automatically will get less depending on the penetration. So see, whatever I am observing, whatever I am showing that arrow mark, so that is penetration. Depending on the penetration, we will get CBR percentage. So based on that percentage, we have to find CBR value. So this is the very important. So like that. So here we are placing two surcharge weight. Two surcharge weight. So see, this is one and this is one. Another two surcharge weight. So see, first one, second one. Two surcharge weight we are placing. So why we are placing two surcharge weight? So only thing, please remember these are two surcharge weight. Later I will tell you what is the reason we are using surcharge weight. This is surcharge, this is surcharge. So we are placing two surcharge weight above the mold. So why? I will tell you later. Yeah, in this slide I will tell you why surcharge weight is very important. So this is this is CBR mode. Okay, and this is payment layers. So see, the CBR mode, it should be simulate payment layers. Why it is simulate payment layers means, so see, here subgrade, okay, another subbase. For one subbase in payment layer, it will matches to one surcharge weight, or it will simulate to surcharge weight or surcharge disk. Another base layer, it will simulate to surface layer. That means in entire payment layer, it will, or entire CBR mode, it will simulate to payment layer. So that's why we are using two surcharge weights. So one surcharge weight should be acted as a sub base, another surcharge weight should be acted as a base. So subgrade means here we are using soil. So that means entire payment we are using this entire payment as a CBR mode. We are keeping in that loading frame, and we have to find, we have to apply pressure, and we have to note down the penetration. Based on that penetration, we have to find CBR percentage. That's why we have to conduct this experiment. And this is the plunger. Okay, so here we will get one doubt. So for surface, why we will not placing any surcharge weight? So for surface layer, see the here thickness, surface layer thickness is 50 mm. For that one we don't want, there is no need to provide, or there is no need to keep any surcharge weight. Okay, next, unsoaked condition and soaked condition. So here soaked condition and unsoaked condition. What is that soaked means? In unsoaked, so the soil whatever in the mold, it should be even. Okay, so whatever plunger, bottom of the plunger, so see this, the bottom of the plunger is directly, entire bottom is directly contact to the soil. But in soaked condition, what happens? After 4 days of water soaking, if you removed whatever soil in the mold, it should be uneven. It may be like this, one case. Another case maybe it may be like this, second case. Why it is like this means, so see soil. Why it is like this means, here the soil should contains more black cotton soil. Means whatever used soil, testing soil, it should contain more black cotton soil. Means it should be highly expensive. Once it is in expensive, sudden volume will be changes. Once it is in volume changes, so see after removing 4 days, the soil surface, it is not a even, it is uneven. So in that case, what happens? So see whatever plunger, so see just you will observe this corner. So only plunger edge should directly contact to the soil, but remaining portion, so this remaining portion, so see this remaining portion, it should not contact to the surface of the soil. On that case we will require correction. So correction is required here. In unsoaked condition, correction is not required. This is very important. So now this is the table. So penetration in mm, PRR in division, P in kg. That means every 50 mm dial gauge reading. So DGR means dial gauge reading, every division. Here I am not mentioned DGR. Instead of DGR, I am directly, I will take it as a penetration. That means least count of DGR is 0.01 mm. So least count of 0.01 mm. So the DGR. So if you multiply every 50 divisions of DGR, 50 into 0.01 is how much it is? 0.5. Like that 100 into 0.1, like that up to 700 means 700 into 0.1, like that we will get 7. So till that we have to continue the experiment, and every 50 division, so it is 0.5, 1.5, we will note on the PRR division, corresponding PRR division, that is we have to convert P in kg. In next upcoming videos I will explain what is, how to read PRR division, and using PRR division how to convert P in kg, and how to read DGR division, and how to convert DGR division to settlement or any penetration value. So that is later I will tell you in upcoming videos. So next, plunger area, that is centimeter square, pressure kg per centimeter square, that is load by area. So plunger diameter is 5 centimeter. Now, so this is very important. So already I said in starting slide. So ratio, CBR ratio means we are comparing soil. We are we are comparing soil to the aggregates. Already I said in first slide. So we are comparing soil to the standard aggregate. Both should be in compacted state. That is in denser state. So denser state means when it is in denser, after compaction only soil should get dense state, right? So like that here. So what I am now I am explaining here, the soil is comparing to standard aggregate. So see, this is the standard chart they are given in IS code. So penetration in mm for 2.5 penetration, standard loading given as a 1370. So similarly pressure should be given as a 70. Similarly 5 penetration 2055, and similarly pressure as a given as a 105. So on what basis they will be given as a values means, so see, for standard aggregates they will be conducted experiments. So after fully compacted standard aggregates, they are, after that conducting experiment, they got a this type of values. Based on that values we are comparing our soil to standard aggregates. So these are the standard aggregates, standard load value and standard pressure value. That's why it is called as a ratio. Because of that only reason it is called as a ratio. That means initially they are conducted experiment for standard aggregates, that is fully compacted standard aggregates. So based on the trial and error they got a standard value. So 1370, 70, and 2055, 105. That means in kg 1370 if it is in pressure 70. So if it is in load 2055 kg, similarly in pressure 105. So based on that we have to take it. And another one doubt, some may have doubts here. So actually this CBR should be, CBR experiment should be, they are using in highway design, but actually this experiment it is in belongs to geotechnical engineering. So why we are using a highway engineering means, so our highway design means, highway lab means, the only reason is here, actually CBR should be used for finding various layer thickness. That means for designing a flexible pavement, CBR value we want. But in geotechnical engineering lab, whatever other experiment, consistency, direct shear test and everything, so we don't want for any highway design. Only this experiment, consistency index we want for highway design, but CBR also we want for highway design. So that's why they are kept in highway lab. So this CBR experiment they are kept in highway lab. Only because of that only reason. So only thing is we have to note down. So we have to remember for 2.5 and 5 penetration. So another one thing. So for finding CBR percentage, only we are taking 2.5 penetration, 5 penetration. We don't want other penetration value. So the reason is for 2.5 penetration, for 2.5 and 5 penetration, we will get more penetration. That means we will get more load value or more pressure. But after 5 penetration, it will not take any pressure. So if you press any material, so a sponge, so whatever up to some penetration, it will take the load. So after that, it will not take the load. So reason is, so once it is crossed the pressure, so it will not take any pressure. So that's why penetration again we don't want. So only 2.5 and 5 So based on trial and error, so only they are considered 2.5 and 5 penetration. They have to find CBR percentage. No, correction. So CBR formula, CBR percentage is equal to unit load or pressure carried soil sample at defined penetration level, and unit load or pressure carried by standard aggregate above the penetration level. So already I said into 100. So unit load or pressure. So already I said for 2.5 penetration. So in numerator that is so in denominator that is standard aggregate 70. So we are taking pressure means 70. In numerator how much you will get the pressure, that we have to note down. So using this table. Okay, if you are in pressure, how much in denominator 70, in numerator how much pressure, that is for 2.5 mm. Similarly for 5 mm, so 105. Similarly for 5 mm here, for 2.5 and 5 mm, how so see, for 2.5 and for 5 mm how much pressure we will know. So that we have to put in numerator and denominator values, that is standard aggregates, that is 70 and 105. Similarly for kg, so see, only we want know that is load in kg. P means load. So in that, using this formula we have to uh, substitute. After substituting we will get CBR in percentage. So in numerator only, see, soil sample and then standard aggregates. So that indicates what CBR means. Here we are taking as a term ratio, means here CBR, bearing already said what is C means, already said. Ratio means we are comparing soil sample to the standard aggregates. So for standard aggregate, that is standard aggregate, standard values. That's why I am telling this standard. Standard means already they are found some values. So we are comparing our whatever getting the value to standard values, how much CBR. That means whatever getting soil values to standard aggregate value, we are finding CBR percentage. Okay, leave that. So now coming to graph. So see, unsoaked graph and soaked graph. So here just we can observe, in unsoaked we don't want any corrections, but in soaked what happens, the curve should go like this. So in that case what happens, we will use correction factor. So see, so we have to draw tangent. So see, we have to draw tangent. So what you have to do means, in unsoaked, so see, 2.5 and 5 mm penetration. So 2.5 5 mm penetration, how much load value we will get. So for 2.5 5 mm penetration, 2.5 2.5 5 mm penetration, how much load value we will get, we have to calculate. So this is for unsoaked. In soaked, what you have to do means, we have to draw tangent. So see, here they drawn tangent. After drawn tangent, this is 0. Now this is 0. Now this 2.5 is shifted here and 5 is also shifted here. Corresponding 2.5, how much load value we will get, and corresponding how much 5 how much load value or pressure value we will get, that we have to substitute in this formula. Into 100 you will get CBR percentage. Okay, direct I will go to problem. So same as whatever I explained. The load penetration values of CBR test conducted on two specimen sample are given below. Determine the CBR value of soil if 100 divisions of the load dial represents 190 kg. Means here two specimens they are taken. It may be soaked or unsoaked, I don't know, but they are taken two specimens. So here 100 divisions of dial gauge, it is indicates that it represents 190 kg load in the calibration chart of the proving ring. So see, so for plunger penetration like that they are given, and the load dial readings are given. So that is specimen number 1, specimen number 2. So now what we have to find, CBR percentage. Now specimen 1, the load penetration curve for specimen 1 consistently. So see, first I will explain graph. So see, here specimen 1, this is the first, specimen 2, this is second one. So see, initially whatever is there, see now it is a, the specimen 1 is totally convex, but here the specimen 2 is totally concave. So this is convex, this is concave. So because of that one we have to use correction factor. That means specimen 2 is totally concave. So this is concave and this is convex. So wherever concave is there, we have to go for correction factor. So see, so based on these two results, x-axis penetration in mm that is given, load value in given. So based on that we have to draw graph. So see, so first I will go for unsoaked condition. Specimen 1 it is unsoaked. So every here for 2.5 mm penetration, how much load value they got. Okay, and similarly, so see, for 5 mm penetration, for 5 mm for 5 mm penetration, for 2.5 mm penetration, how much load value they will check here. So 5 mm how much it is, and for 2.5 mm how much it is they taken. Similarly for soaked condition they draw, okay, they drawn that is tangent here. See, so once it is drawn tangent, so now this is take it as a 0. Now this value is taken as a 0. Now 2.5 is shifted, 5 is shifted. So now once it is shifted, the value for 2.5 mm how much load, okay, how much load for 2.5 mm. Similarly for 5 mm, for 5 mm how much load, that value they will be uh, taken in formula. So now I will coming to this specimen 1 formula. So see, the load penetration curve for specimen 1 is consistently convex throughout and needs no correction. Load diving with 2.5 penetration is 34 division, that is given. So at load at 2, already I said only for finding CBR 2.5 and 5 mm penetration we have to find CBR. So 2.5 penetration 34 division is given. 34 into 190, load given is how much it is, 190 kg. 190 kg for 100 division they are mentioned in that question. So that's why how much we will get, 64.6. Similarly, CBR value for 2.5 mm, CBR value for 2.5 mm penetration is equal to 64.6. Now, so see, already I said. So we are comparing CBR value of soil. This is soil, this is aggregates. So here we are taking load value, right? So load value, that's why 1370, that is standard value for 2.5 mm. Similarly, for 5 mm penetration, 48 division we got in graph. So 190 by 100, 91.2 kg will get. But here, 2055. 2055. So see, 2055, this is standard value. 1370 that is standard value, that is standard aggregate value. So at 64.6 and 91.2, that is we found in CBR test. So that means soil to aggregate we are comparing. So this is soil, this is soil, this is aggregate we are comparing. So soil to aggregate into 100 you will get CBR percentage. In the 2.5 mm and then 5 mm, which one is the highest CBR value we have to note down. So see, so here 4.7, here 4.47. So here in highest is 4.7. So this is the highest value, that's why specimen 1 is in that, which one is highest, 2.55 mm, which one is that we have to consider. 4.7 is highest, I am considering this one. Similarly, CBR specimen 2. So here the penetration curve for specimen 2 is consistently concave and needs correction factor. Already I said how to correction. Okay. Low Dale readings after 2.5 penetration, how much it is, 30 division. 2.5 penetration is how much it is, 30. 30 into 190 divided by 100 is equal to 57 kg. Similarly, CBR 2.15 penetration is how much it is, 57 divided by 1370. This is standard value. Similarly, 2055, this is also standard value. For 5 mm, 2.5 mm, we will get CBR percentage. Here 4.16%, here also 4.16%. So here both are 4.16, so we will take it as a 4.16. Now the average CBR for specimen 1, specimen 1 and specimen 2 divided by 2. So see, specimen 4.7, specimen 2 is 4.16 divided by 2 is how much it is, 4.43%. That means CBR value is 4.43%. This is the standard. So this is the final CBR percentage for the particular soil mass. So this is the problem of CBR. So till that whatever I am explained, so this is CBR percentage and then CBR of soil. Thank you.